So this is a discussion menu. Question is practice of week 1, question O. So the first thing would be still using my charts. Are we missing anything? That's always be your first thing of doing resonance structure. Are we missing anything in this structure? Are we missing charge? Are we missing lone pair? Okay. Actually, there is a pair of lone pair. Am I here? Yeah. There's a pair of lone pair. Okay. Why there's a pair of lone pair? Okay. When oxygen is happy, there should be a pair of lone pair when oxygen bound to do 2 different things. That's the bottom of our node 2, the chart, right? So this case, oxygen is happy because it's bound to 2 different things. Are we good? Okay. And then we can start to draw resonance. Okay, I'll show several ways of doing this. One way, because we did a several steps, so this way I'll push directly to the top. We can do several different ways. I'm just showing one way of doing this. Okay, so that would be that's one way of drawing the resonance in this case. It's being color-coded, so the red bond is here. The red bond is braked. Because it's braked, this carbon, okay, the red carbon I'm pointing at is missing a bond, right? So refer to my notes 2, not 3, but bottom page. There was like a whole missing watts changed from charge to watts. So there was a table. It kind of like the same thing. This carbon is missing a bond, and then the electrons take negative charge. It's leaving, so this carbon should be positive. Are we cool with this? Okay, and then there's forming a new double bond here, because we just push a bond here, and then make this carbon too crowded with electrons, so it's pushing the electron from here onto the oxygen on top. Are we cool with this? Okay, I can show another way of doing this, which is you don't push all the way over. Okay, so what if I just load it here? I don't move. That's still can be okay. That's what I meant by we combine 2 steps, but in this case, okay. It's very rare though, but it's this is still, I'm just showing if you have multiple steps. So your next step could be this one push here and push this one on, which is, basically that's if you do stop at halfway, this is how the structure looks like. Are we good? Sorry,
so that structure is halfway between what we would do to get to that one.
Yeah, but this is also a correct resonance structure.
Oh, okay.
It's or if I want to teach in the previous question way, I would be teaching like, okay, if I stop here, I will be keep pushing. Okay, that would be the resonance to this one.
Okay.
Are we cool? Yes?
So why is there the plus on the carbon there?
Because you are breaking this bond. Previously, this carbon has an electron, and this bond is being transferred, so you're missing an electron. Okay. It's carbon, this carbon. This bond is 2 electrons, right? You're missing one, so your carbon will be positive. And also, if you don't know why this is positive, check with our chart, okay? Check with our chart. This carbon is, okay, previously 1, 2, 3, 4, right? Which was neutral, it was happy, right? how about this one? I didn't touch the hydrogen, right? So 1, 2, 3. So it should have a positive charge.
Okay.
Am I lost you?
Okay, it's positive because it's missing one, right?
Yeah, okay, but keep in mind, positive and negative, they're all bound to 3 different. I might keep pushing you, okay? But the negative have another pair of lone pair. It's actually a good example to show this. What's the difference between this one and this one? There's a pair of lone pair. Okay, so okay, I draw out all the things bonded to both carbon. They are all bonded to something like that. They're all one hydrogen that's haven't been drawn out. The only difference why you are all bound to 3, but why this one is a negative, because it has an extra pair of lone pair. This one is positive. So refer to our chart here. They're all bound to 3 things, but this one has an extra pair of lone pair, so it's negative. This one is positive.
Would it be another resonance structure if, like, these two switched? Like, if the double bond went to this carbon instead of this carbon?
Yeah, that's also correct.
So
This-
would we
yeah.
have to write out both of those?
Yeah, if this one show, you probably need to, because they are still correct resonance structure. But I guess this one would not be like your TA will find a happy way that's there. They're not grading too much.
Okay.
Yeah.
The answer key only shows 3 resonance structures. It doesn't show like when the lone pair goes on the outside, like what you drew for the last one.
That's not a common one.
It's not common. Okay.
That's why. Yeah, the resonance. Well, the answer key probably show this one.
It shows all 3 of those with the double
The
bonds, just like different locations.
I kind of like I want to show this one just to separate. Like that's also possible because when you draw resonance, sometimes you cannot push through, just in one step. You might want to check. Okay, am I good here? Is my carbon? So it is. I think. Okay. I know it sounds scary that you need to draw all the resonance structure. How do I know if they are all? We meant to quiz you on. You do know how to push through, but the requirements of your quiz is more or less like, okay, there are some people who cannot push all the way through. If you just stop halfway or somewhere in between, like we still count them as correct structure. That's why we said you need to draw all. It's not meant to give you a hard time on this. Are we good?
So we can push from the bottom.
So as long as it's a correct structure.
Okay.
Yeah, so the only thing we don't want in quiz 1 would be like you put both negative, it's a wrong structure, then you will be mark points down. Are we good with this? Okay.
I have a question about a similar problem like this.
Okay, and we post